All right, here we're going to talk about sound, sound characteristics. What is sound? So jumping right into it. Sound is a longitudinal mechanical wave. And usually we're talking about sound traveling through air, but it can also travel through liquids and solids. So sound does travel through liquids, it does travel through solids, but usually when we're talking about sound, we're talking about it traveling through the air. The loudness of a sound is determined by the amplitude of the wave. So a sound is loud if it has a big amplitude. A sound is quiet if it has a small amplitude. And then the pitch of a sound is determined by the frequency / wavelength. But mainly the frequency, because that's usually what we base it off of. So a high-pitched sound is a high frequency. A low-pitched sound is a low frequency. And that's actually, those language match up for that reason. That's why we say high pitch, high frequency, low pitch, low frequency. So in other words, a high-pitched sound is one where the medium is vibrating really fast. A low pitch is where the medium is vibrating slowly. Loudness means the medium is moving a lot back and forth. Soft sound means the medium is moving only a little bit back and forth. So how does this actually work? Well, what happens with sound, and this is probably something we'll also talk about in class a bit, is imagine you've got a drum. So drums are the easiest way to think about this. So what's going to happen when that drum gets hit? It's going to vibrate. And what does that mean when it's vibrating? It's going to move back and forth. Now, in front of the drum, or to like say the right side of the drum, there's air. Now, when that drum moves to the right, it's going to shove all that air together. So what we're going to get is a bunch of air really close together. So all those air particles get bunched up. So we have this high pressure zone, a place where there's a lot of air compressed together. Now that air also gets shoved. So what does it do? It shoves the air next to it, and we get this high pressure zone start moving to the side. Just like if you imagined putting a bunch of people, or just like if you imagine on the bus, and then if you don't do this because it's terrible neighborly, but if you're really packed into the bus and then someone at the front of the bus just shoves everyone, then you can, you imagine that the people at the front of the bus initially get squished together, but then they bump the people behind them, and that squishiness gets passed back. So now, while that squishiness or that compression is moving forward, what does the drum head do? Well, it's vibrating, so it moves back, like it pulls back away from those air particles. And so what does that do? That creates this gap. So imagine that all this compressed pressurized air is now up here. So now behind that compression, there's a gap where there's not a lot of air particles. So it's low pressure because the drum has moved away. So the particles are moving forward, and then the drum's moving back, and it creates that space. It's just like on that bus example, the person, pushed and shoved forward and then backed up, and that creates a gap between the people. Now, what's going to happen as time goes on? Well, the particles, like the people that were kind of on either side, are going to slowly start to filter back. And that means, that we start getting the pressure normalizing again. And so if you just have one shake of the drum, that's what you'll see, is you'll see a high pressure kind of pulse followed by a low pressure area, followed by it kind of dying out to normal. But now if this drum keeps vibrating, it's like the person at that front of the bus shoves everyone. They all kind of compress, and that compression starts passing. There's a gap behind. As people start to come back to fill in that space, the person shoves them again. And so what then you'll get is these alternating pattern of you'll have a really compressed thing of air followed by some spread out air. And then some spread out air, really compressed, close together air. And so what you end up having is these end up becoming, we say, our peaks because they're places where the pressure is high, and these end up becoming our valleys because the pressure is low. And actually in this case, the amplitude is the difference in pressure, not actually, which is related to how much the air particles move, but that's our amplitude. So a loud sound is just one where the pressure gets really high and then really low. A soft sound is where the pressure stays pretty even, maybe a little bit higher pressure, a little bit lower pressure. Now, the pitch is going to be just how close those peaks are packed in together. So if it's quickly going from high to low to high to low to high to low, then that will be a high frequency. If it's going slowly, if it goes high to low to high to low, that's low pitch. If you're wondering how that relates to us hearing, just real briefly, what ends up happening is your eardrum, there's a membrane, and what that is just the reverse of this drum that's creating the sound. You'll have these high pressure stuff, it will push in on your ear, and then when the low pressure zone comes, it will pull out on your ear ever so slightly. And then you've got all sorts of fancy stuff inside that eardrum that basically detect those pressure differences, and then your brain interprets that. This is why if you go to high altitudes quickly, like when you're flying in an airplane or driving up a mountain, why it gets hard to hear, because what actually happens is the pressure hasn't equalized, so either your eardrum is kind of pressed in more than it normally is, or it's expanded out more than it normally is, and then it doesn't have as much ability to move back and forth because it's used to being kind of in the middle, but if it's already pressed out, it can't come out and in that much. If it's, pressed in, it can't go out and in that much. So you can still hear because there's still some vibration, but not nearly as much as when the pressure inside your ear and outside is equal, and it can vibrate the full amount. So that's why sounds will sound softer, because the amount that they cause your ear to shake is less, and your brain doesn't know that's because the ear is under pressure. It just knows, oh, it must be a soft sound. If you have questions or want to talk about that further, let me know. But the main thing we want to focus on here is that model of high, low pressure being sound, and then the loudness relating to the amplitude and the pitch relating to the frequency.